Today's video will demonstrate how the Deque's pushback method works. Hello, I'm James Helfrich. The Deque is a unique data structure in the C++ standard template library, and it is built from an array of arrays. And this enables us to do pushback in os of 1, even in the worst case scenario. This video will demonstrate exactly how that works. Recall that there are actually 4 different implementation options for the Deque. The first is the list. The list is really great because it's easy to do push back and push front, pop back and pop front, all in os of 1. Unfortunately, though, it's impossible to do the square bracket or the array index operator in os of 1. That's os of n, so that's not a very common implementation. The next is a wrapping array, and a wrapping array is very efficient to go push back or push front, pop back and pop front, and even do the array index operator. However, reallocation is os of n. The next is use an array of pointers. Now, the interesting thing about this is we don't actually move the elements when we reallocate, we just move the pointers. So it's os of 1 with regards to moving the elements themselves, but it could be os of n with reassigning the pointers. And finally is the array of array implementations. And this is what the standard template library uses, and we're going to demonstrate this right now. Okay, so the Deque is an array of arrays. So for an example, if I have 6 elements, A, B, C, D, E, and F in order, then it might look like this in the implementation. On the bottom is my array of pointers, and the 3 columns are going to be my arrays that actually contain the data. Now, the Deque indices are 0, 1, 2, 3, 4, 5, and this is what the client sees. So if I say, hey, give me Deque of 3, I'm going to get the element D. Now, there's actually going to be 5 different blocks here, and each block is going to have a block index. Block 0, block 1, block 2, block 3, block 4. I call it IB for block index. Notice block 0 and block 1 are not currently allocated because I'm not using them right now, so they have a null pointer. Now, each block is going to have a collection of cells. In this case, we only have 3 cells. Normally, Deque is going to have a large number of cells, maybe 8 or 16. But right now, I'm just going to do 3 for demonstration purposes. So I call it cell index 0, 1, and 2, IC. And then finally, and this is perhaps the most difficult to understand, I have array indices. Assuming that all the blocks are allocated, I'm going to start at the upper left-hand corner, array 0, and go all the way through. And now that means that D is going to be array index 10, it's going to be block index 3, and it's going to be cell index 1. Okay, I can even represent the same thing by putting all the blocks stacked side by side for each other. This is exactly the same Deque we had before, but perhaps a little more intuitive to see. Now, in this case, I have my Deque indices 0, 1, 2, 3, 4, and 5. So once again, D is Deque index 3, and I call it ID for Deque index. And then my block index 0, 1, 2, 3, 4. And my cell indices are 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. And then my array indices are 0, 1, 2, 3, all the way to 14. Now, notice that the Deque index 0 is array index 7. So I'm going to say IA front, or the index of the front element of the Deque is 7. And we're going to have to remember that for later. Okay, so how do you push back? Well, it's a 3-step process. We reallocate the array of blocks as needed, then we reallocate a new block as needed, and then we assign the value to the block. So first of all, I'm going to reallocate the block as needed. I'm going to figure out what the cell index of the last element is, and then I'm going to say, hey, look, if all the blocks are filled and I'm at the end of my last cell, then I'm going to need to reallocate. Now, after that's done, then I say, hey, well, maybe I need to have a new block. So I'm going to find the block index of the last element. If that block index is filled, then I might need to create a new block. Now, if I have a block for my new element in a cell, then I can just add it to the end. Notice my comment, this is gnarly. It turns out that allocating and adding an element to the end of a multidimensional array, the C++ code is a little bit nasty for that. Okay, let's demonstrate how this works. So first of all, I'm going to have a Deque that has A, B, C, D, E, F, and G in it. So I have 3 blocks currently allocated, but I have space for 4. So if I say push back H, well, I'm going to start here, and it looks like I have plenty of blocks. It looks like my block actually has a cell, so I don't need to allocate a new block. So now I'm going to put the letter H into that spot. Now I want to push back I. So it looks like I still have an extra block, so I don't need to reallocate, but I do need a new block for the letter I. So I'm going to have to allocate a new block, and right now it's empty, and then I'll push back onto that slot. Now for J and K is pretty easy, but for L, I'm in a new situation here. Here, it looks like all the blocks are allocated, so I need to create a new array of pointers. So reallocate is going to allocate a new array of pointers. It's going to point these elements to the existing blocks, and then it's going to get rid of my old pointers, and it's also going to get rid of my old block. Now I have space to create the new block, and now that I have a new block, I can put the element in. Okay, so obviously a great deal of work is done in reallocate. Let's take a look. So to reallocate, I need to allocate a new array of pointers. That's the required size. Then I need to copy the pointers from the old array of pointers to the new one. Then I want to set all the block pointers to null when there's no block there pointed to for all the extra blocks. And then I got to change the Deque member variables to point to the new block and the new values. Okay, so reallocate. First of all, I'm going to allocate a new block of pointers of the required size. I'm just going to allocate it. And then I want to copy the pointers over. Now notice I need to unwrap as I go. And we're going to see why that is because my demonstration in just a second is going to show the blocks in a wrap state. And I need to unwrap them. Otherwise, I'm going to have a gap in a funny location. And then I want to set all the extra block pointers to null, the ones that are not currently allocated. And then I want to delete the old array of pointers and then update my number of blocks value and update my IA front value. Okay, so take a look at this. I have A, B, C, D, E, F, G, H, and I. Now notice I'm in a wrap state. So the first element A is not in block 0, but rather in block 2. And this is fine because this could happen as I push back and push front and pop back and pop front in various locations. I could get myself into a wrap state. But if I just copy those pointers over to my larger block size, then I'm going to have the gap between the front and back in the middle of my block, and that's going to be really weird. So I need to unwrap that. So step number 1 is going to allocate a new block. Step number 2 is I'm going to one by one update the pointers. So I'm going to say, hey, this guy points to the front, and then this one, and then this one, and then that one. Now notice that A, or the beginning of my Deque index 0, is now in block 0. I have to make sure that the blocks are in order when I unwrap it. And then I'm going to take all the extra blocks and assign them to the null pointer. And then I'm going to delete my old array, and then I'm going to update my values, and I'm finished. You can learn more about how the Deque is implemented, including all 4 implementation options, in the Deque chapter of the C++ data structures textbook.